Boop. I have now pushed the button. I'll talk about the recordings in a moment. Um, so what Feynman meant here is that often in physics is a science of simplicity. And often, if you're trying to figure out what's going on in a particular problem, think simple, because the answer is more likely to be simpler than what you think rather than more complicated than what you think. I will be right back. I need to move something for a student. I'm going to get that out of your way. Um, this is very heavy. I got it. So on Discord last night, one of your classmates wrote something like, "I feel like all we've learned so far is position equals 1/2 at squared plus v naught t plus initial position." And you're right. We've really only done one thing, and then its consequences. But that's what physics is. And that student who said, "Oh, I feel like I've only done one thing," that student understands physics, understands what we've done, because once all of the things that we're doing seem like different manifestations of the same thing, that means everything is starting to come together. I'm leaning forward. I'm going to adjust the parameters on the chroma keying just a little bit to make things flicker less. Um, yes, that was Yunsji in Twitch chat who said that on Discord last night. That comment is very astute. So we're going to do one more thing today, and then the first exam is really going to be on the two things we've done. The second quote that I'm using as our epigram today, Feynman wrote, "Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry." What Feynman means there, again, is that physics tends to repeat itself. Once you understand, say, motion with constant acceleration, you can apply that to very many situations. And what we're going to see today is that to understand motion in 2 dimensions, all you need to do is to combine 2 copies of motion in 1 dimension. People are talking about the Mars landing. I would love to talk about the Mars landing today. Unfortunately, I have been up to my eyeballs in stuff to do, and I don't know what's going on with the Mars landing. So if you all could educate me, I would really appreciate seeing that in Twitch chat. Niklik, I think so a Kyrie is a movement in the traditional mass. A Kyrie is a basketball player who doesn't know what shape the Earth is. People are booping. What are people saying? People are pogging a lot. Okay. I'm just scrolling up. Yeah, people are complimenting the music. So I will. I'm going to play music before all the classes. So if you get here a little bit early, I'm going to play music that's somehow appropriate to whatever we're doing. All right. So some announcements. Your first homework set is due tomorrow. Again, sorry about the black bar. We're still getting stuff set up. That'll be gone soon. Your first homework set is due tomorrow before recitation. The reason it's due before recitation is your recitation evaluation tomorrow. We will ask you a simple question about the homework that you're turning in. We have a moment, some time today to answer your questions about that homework set. We've also gotten lots of opportunities for you to seek help, to get help. One of them is asking questions here. So after I'm done with the announcements, we'll have some time for you to ask me stuff about the homework, and we can talk about it. One of them is the virtual physics clinic, but I understand there was some kind of a malfunction yesterday in the virtual physics clinic. So I was CC'd on a whole bunch of emails this morning. What went wrong? So I see people memeing about the Mars landing in Twitch chat. Uh, please physics mode for a bit so people can tell me what's going on. While they're typing, Mia asks in Zoom chat, is it okay if you have 2 questions on 1 page? Earlier I said 1 question per page. The reason I said that is because some students, and I was one of those people when I was an undergrad, had a tendency to like try to smash all their homework on 1 page. And the problem with that is you can't read your own writing. And you get confused because you're trying to like do a problem in this much paper. Paper is pretty cheap. But as long as you can read your own writing, and as long as you take the time that you need to explain yourself, Mia, then it's fine. We're not going to be like, we are not your really strict 8th grade algebra teacher, right? We are pretty laid back in this class. So as long as, these guidelines we give you, like put 1 question per page, these are really to help you understand things better, not because we're super picky. Lumbo says the virtual physics clinic exploded. If you could tell me a bit more about what exploded means. Regardless, we will try to fix those problems. So I'm going to be in the virtual physics clinic today from 3:30 to 5:30. But lots of other people have lots of other hours in the virtual physics clinic. So see the course website, and it will tell you when everybody is going to be there with the whole schedule. We have coverage late into the night in the virtual physics clinic often. So you look at the schedule, and also every night I have been on Discord. People have been like talking about the homework on Discord. So the Discord server is a really good spot for you to go to talk about what we're doing. Like, lots of folks are asking questions. Lots of folks are answering them. Amazing Maxiplier says the people in the clinic were helpful, especially Adam and Connor, both of whom are, I think I've got the slang right. Both of them are goats. I'm not quite sure why it's good to be a goat, like the things with the horns that eat tin cans, but I think both of them are goats. Yes. So, second homework set will be posted tomorrow and will be due next Thursday before class. Why is it due next Thursday before class rather than before recitation? Because your first quiz is next Thursday. And Zoom chat, yes, I know that. See, I'm an old man, but I know some of the memes, but I get to like joke about the fact that I'm a clueless old man, even though I do know a little bit. Yes, I know what GOAT stands for. But goats are pretty cool. I had a buddy when I was in grad school who he and his wife were always talking about how they wanted to like own goats. He is also a physics teacher. So first quiz next Thursday. Don't panic. I've seen messages from folks on Discord saying like, I feel like I'm still learning, is what they all amount to. Yes, you should feel like you're still learning. You are learning. That's what this class is for. If you're here, if you're following along, you will be fine for the quiz on Thursday. The quiz will be 2 questions. Now, I've listed 4 things that will be on the quiz, so you might imagine that more than one of these things will be in each question. Here are the promises of what will be on the quiz. One of them, I will give you a problem where you have to use the quadratic formula, and it will spit out 2 roots. Like question number 5, the Roadrunner problem from homework 1. And in that problem, you got 2 roots, and you have to interpret them. You will have to do that on the quiz. Yes, my shirt is transparent. It's supposed to be yellow, but because I am tweaking the chroma keying settings in Open Broadcaster Studio on the fly, it's thinking that yellow is green. I will fix the chroma keying, or maybe I'll just wear a green shirt and look really bizarre. I will fix these things. Like this laptop I bought at 12:30 p.m. yesterday and spent yesterday messing around with Asus drivers. So one question will be like question 5 from homework 1. One question will involve motion with constant acceleration in one dimension. So this is all of what homework set 1 was. It's like the Roadrunner problem, problem 5 from homework 1, the bicycle problem, also the elevator problem for homework 2, which I will post tonight. There will also be motion with constant acceleration in 2 dimensions, which is what we will do today and next Tuesday. So on homework 2, the cannon problem and the dog problem will kind of be like references for, if you understand those, you will understand what will be on the first quiz. You will also need to interpret or make position velocity acceleration graphs, like you had to do for the bicycle problem on homework 1. Other things about quiz 1, and then we will have a moment for questions. There are a couple of review opportunities for you. Next Wednesday, I will be having extra help hours on Zoom. That's in addition to the usual help hours that I have, that I'll be having today, tomorrow morning, and next Tuesday. I'll send out all of that. I'm going to send you all like a big email with everything in one place tonight, so you don't need to write all this stuff down, right? These slides are posted on the course website, but also I'll put it all in one email and send it to everybody. But the quiz will only take you an hour to do. And class is an hour and 20 minutes. So the first 20 minutes of class next Thursday will also be an opportunity for you to review. Agleschalt, yes. After I talk about this, after I tell everybody what will be on the quiz, then we will talk. We can do homework hints. Porpay says I should wear a green bodysuit. I don't have one, but if someone wants to send me a green bodysuit, I will wear it, and I can be a floating disembodied head. Actually, I do have a green shirt, so I guess I just need to get a green mask. And I could dye my hair green. Don't tell Alice I said that. So next Thursday, how will the quiz work? So the quiz is so the quiz will start at 11:20. So the first 20 minutes of class from 11 a.m. to 11:20 a.m. will be review, a chance for you all to ask last-minute questions. But then at 11:20 a.m., you will have access to the PDF. Siddiqui, in a minute, you can ask homework questions, and we'll give you help right now. You can get that PDF, and then you have an hour to answer the 2 questions. We'll say that it's due at 12:20 p.m. at the end of class. But since it'll take you a minute to scan and submit stuff on Blackboard, there will be a grace period after 12:20 for you to get your stuff submitted. And you've got 4 options on how you wish to do the quiz. One of them is to look at the PDF, put it on your computer screen, write the answers on your own paper, scan them, submit them. You may also, if you have a printer wherever you are, print the thing, write the answers on the printout you make, scan that, and submit it. If you don't have a printer, that might be harder. You can also, if you have an iPad or equivalent device, you can get the PDF, write stuff on it with a stylus, and submit that PDF. Many students choose to do things like that. Finally, we have a limited capacity for some students to take the quiz in person. So for if you choose to do that, then you would come to a room that we set aside. We will have a room for you to take the quiz in. You will come, we will hand you a piece of paper, you will write on it, and then you will give us something at the end of class. It might make it a little hard for you to participate in the review. We will figure that out to the best of our ability. Obviously, you can bring a laptop with earbuds. We'll sort all that out, but could I get a sound off in Twitch chat or Zoom chat of who might be interested in taking the quiz in kind of the conventional way where you come to a classroom and we hand you a piece of paper? Who might want to do that? Missing No says that they might want to do that. Abuel says maybe, depends on where, maybe. It'll be somewhere in the physics building. We gotta find rooms based on how many of you there are. It sounds like there are not that many people, but there are some. Are you raising your hand? Yeah, I'll send out instructions. It seems like we'll get about 20 people set up for that. Um, Lastly, well, this is supposed to be a separate thing. There was a question about ODS students. If you have an extra time accommodation through the Center for Disability Resources / the Office of Disability Services, you will get that extra time. We will figure out how to do that on Blackboard, and we will send you instructions next week. Okay, so before we move on to the new topic for today, um, does anybody have any questions about the homework, about the things you did in recitation yesterday? I see people talking about the homework. Um, Anything folks want to ask? Don't just say, like if you say, how do I do problem 5? I will ask you, how do you think you should do problem 5? But if you have a particular aspect of a problem you have started and would like pointers on, please say so now. Um, Sky asks, is the grading on the quiz the same as everything else? Yes, an 80 is an A minus. The real Fusus, do we have to have a numerical answer for problem 7? This is the one where we ask you to estimate how much snow falls on the quad. Yes, you do, but that numerical answer should be an estimate. So for instance, if you say, it's about 10,000 tons, then that's fine, right? But we'd like you to show us where you got your estimate from. Why 10,000 tons rather than 1,000 tons or 100 tons or 1 million tons? Yeah, Kwame, the camera does lose focus when I step out of frame, but if I'm standing here, we'll get it fixed. Oh, Kwame, maybe you're saying that the Zoom quality is bad. Let me investigate that. If Zoom, actually, could some of the people in Zoom confirm? It seems to be okay on my end, on my monitor, but Zoom sometimes messes around with video quality, and there's nothing I can do. That's on your end. Okay. So let me catch up. M. Mathis says, I am confused on how to interpret the two answers in question 5b. Cassafras 37 asks something similar. So let's talk about that. So I'm going to make the slides go away. I'm going to switch back over to the Blackboard, and we'll talk about it. Good, Miles. Thank you for that feedback. If there are consistent video problems or audio problems, please tell me, and I will fix whatever is wrong. Okay, so I need to push this button, and then I got to turn off green screen. Boop. There we are. Now, in order to talk about 6b, I need to move this out of the way, and we'll see the chalkboard. So, folks who are asking about problem 6b, this is the Roadrunner problem. So, in this problem, I give you the hint where I ask you to graph the Roadrunner's position, or the car's position versus time, and that will help you. So let's talk about problem 6. Oh, are you saying sound is too low? Mic input volume is a tad low. 1 second. I have, okay. Level check, level check, level check. Is the sound, is this better? I'm looking, I see a peak about -4 decibels now. Tell me if I'm too loud, if I'm clipping. Thank you. Joseph, check sound mixer options on Windows. I don't use Windows, I use Linux, but yes. I haven't used this before to broadcast, so I'm still setting things up. Okay. So for the Roadrunner problem, we need to understand the motion of the car. Now, what, we're clipping a little. All right, let's fix it. Boop. Take a couple decibels away. So let me catch up on Twitch chat. What are people saying? So Porpoise is offering the hint, draw the whole graph. So what does the graph of position versus time look like for the car? Yeah. Question 5, right? This is question 5, yeah. And yes, our Martintine, we can also go over number 6. It's a parabolic function. How do you know? Well, remember, position as a function of time is 1/2 at squared. We'll switch colors. Plus v naught t plus x naught. So this is the graph of a parabola. Now, in this expression, so many people choose different coordinate systems. I'm going to choose the initial position to be 0. So I'm going to choose my origin to be where the car starts. So this position will be the starting position of the car will be x equals 0. And we'll have the car be traveling in the positive x direction. So let's talk about these terms in this equation. Is a here positive or negative in this question? Yunsji in Twitch says it's got to be negative. Yep. So this is negative. We know it is negative because the car is moving forward, which is the positive direction, but slowing down. So if we were to draw a cartoon of this, remember physicists love cartoons. Here is our road. Here is our car. I'm going to draw it in red because I have a red car. Here's our car. And our starting velocity is this way. We'll draw the Roadrunner in orange. They're kind of orangish birds. So I don't know how to draw a bird, so please forgive me. There's a bird. Is there. So we have chosen this position where the car starts to be x equals 0, and this direction forward to be plus x. This is always a good idea to do for any problem. To draw a cartoon of what's going on and label on your cartoon a coordinate system. So to choose which location is 0 and which direction is positive. So given this, which way does the acceleration in this problem point? Left or right? So de Bruijn-Slayek says the car is decelerating, which means it is moving less and less to the right. So people are saying that the acceleration is to the left. Right. So the acceleration here is negative. So what that means is this term is negative. Now, if you have a quadratic with a negative in front of the squared thing and you graph it, you will get a function that looks like this. So that's a concave down parabola. And this makes sense. We know the velocity is the slope of, let's gut check what we're doing. And again, if you all want to say something, wave at me. I will move my headphones and you can say stuff. So the velocity at any given point is the slope of the tangent line to the graph. So here at the beginning, the slope is large, but later the slope is small. So if the slope is large, what does that mean? What does it tell me that the slope of the position graph is big here and small there? Yeah, large and positive. Yeah, it's a high velocity. So if the slope is large, we've already got that from our cartoon. If the slope is large, the velocity is large. If the slope is small, the velocity is small. Does this make sense? Does it make sense that the velocity is larger at t equals 0 and smaller at some later time? Yes, because the car is slowing down. That's in the problem. So our graph now matches our understanding of what this car is doing, right? And Sad Ferret Boy says, well, it goes fast, it starts slowing down, and then they said it starts accelerating in the negative. So here, the slope is negative, right? The slope of the tangent line. So this is moving backwards? Question mark? I'll leave that question mark there. We can get rid of this text to unclutter the blackboard, because we've already observed that this is negative. Now, here I've just drawn the car, but what's the other element in this problem? Sorry? The bird. Yeah, how do I like label the bird on this graph? What do I do? What's the bird doing?
The position.
Sorry?
What different position is it?
A different position. So if I were to like label the bird's position, how would I mark that on the graph? Twitch chat has got it. It's just a straight line. So for the bird, its position is constant. It's sitting in the road. It's trying to eat a lizard. It's not going anywhere until it hears the car coming and says, oh, crap, I better get out of here. So the Roadrunner is just chilling here at a position of 30 meters down the road. Now, so why did I put this problem on the homework? This is all of my homework problems. So just as a thing, I write all the problems, the homework problems in this class myself, and all of them are designed to teach you a specific thing. What this problem is designed to teach you is to be smarter than math. Math gives you two answers. So the quadratic formula you know, tells you two times. There are two roots, as Sad Ferret Boy says. Only one of them makes sense. So what are the two roots that the quadratic formula gives you? How would I label them here? So the two zeros. Yes, the quadratic formula tells you the two zeros of a quadratic. So this equation here, I'm just going to clean up the board. Gives you the position of an object undergoing constant acceleration at any time. So what do we have? 1/2 at squared. Note that this is negative. Plus v naught t plus x naught. Now, the way that we are used to solving quadratics is to shove everything on one side and set the rest equal to 0. But really, what the quadratic formula will do for us is it will tell us when a quadratic equation is equal to any other expression. So it gives one way to think of what the quadratic formula does conceptually is it tells you where parabolas intersect lines. Soryudo says, wouldn't you need a polynomial formula first? Yeah, this is a polynomial, right? There's the squared term, there's the linear term, and there's the constant term. So the quadratic formula tells you where parabolas intersect lines. And someone has said the points where the car crosses the roadrunner's position. A couple people in Twitch chat have been saying this. So the quadratic formula will tell you these 2 points. Now, this equation we've got that gives us the position as a function of time for the car, that equation doesn't have a restricted domain, right? I can put in any value of t I like, and I can get the position as a function of time. And it's up to you to be smarter than your equations. This equation is valid only under a particular circumstance. Remember, when we did the derivation of this equation, we assumed something about the car's acceleration. What is that assumption? Lumbo, I'll talk about that in a minute. Yes, as Dragoon Slayak says, we have assumed that the acceleration is constant. Is the acceleration constant in this problem? Yeah, Miles said that on Twitch. So Siddiqui says, no, acceleration is not constant. Now, we can't use this at all if the acceleration is never constant. But Siddiqui, I think you're onto something. So would you say no, the acceleration isn't constant? What do you mean and why? Sydney T, I will come back to that in just a moment. Yuns G says, and if you want me to pronounce your Twitch handles in a different way, please let me know. So educational purposes says, ? Acceleration is constant in this equation. Missing No is informing me about their personal hygiene. Thank you. I needed to know that. Take your AirPods with you. Don't let me know. Sidney T says it's constant until it stops. So the assumption we're making here, if we say that this parabola is valid for all time, what this tells me is that in the past, my velocity was even larger, right? That if I'm going 120 kilometers per hour at this point, then I was going even faster a little bit in the past, and that I go forward, I slow down, I slow down, I slow down, I stop. I go backwards, I go backwards, I go backwards, I go backwards, and then I'm going backwards faster and faster and faster in the future. So if this equation is valid for all time, then what this means, so this is the road from Tucson, Arizona to Nogales, Mexico. So this means that like 15 minutes ago, I left Mexico traveling at 500 kilometers per hour, and then 15 minutes from now, I will go backwards over the Mexican border again at 500 miles per hour. That's not happening, right? This equation is only valid for the period of time when acceleration is constant. The problem doesn't tell you anything about what happened back here, for instance, because we know that the driver doesn't apply their brakes until this moment, right? Before the problem starts, before t equals 0, the driver has not applied their brakes yet. The acceleration was not the constant value of 9 meters per second backwards. So all of that, the thing the math is telling me doesn't apply. I'll leave it to you to think about what happens over here and to relate the story being told, which is how long does the roadrunner have to get out of the way, to this picture. And Oatmeal SU says it's really just half the parabola. I will leave you all to do the rest. Gislo says the camera is crooked. I will fix that in a minute. There was a question about significant figures for homework. We are not in a math class. We are in a physics class. We use numbers because they mean stuff. You all are in training, many of you, to be engineers. Your numbers will mean stuff. When you use significant figures in your problems, if you're deciding whether to put down 1 digit, 2 digits, or 10 digits, think about what you are communicating. Are you really measuring these times to the nanosecond? Probably not. People are asking about unit conversions. If you are comparing things of unlike dimension, then or unlike units, then yes, you will need to convert one thing to match another one. Oatmeal SU says, yeah, we set our reference points to be from like t equals 0 is when she hit the brakes in this, yes. I unfortunately need to move on. This is the problem I was hoping you all would ask about. I've given this problem before. People ask about it, and we always do this on the board because this sort of thinking is very important. So you've got 2 answers from the quadratic formula. They're both positive, so you can't just do what you did in high school and throw away the negative one. You have to think about what they mean. And I'm going to ask you to do something like this on quiz 1. That's a promise that will be on quiz 1, where you will have to use the quadratic formula. You'll get 2 roots, and I will ask you to physically interpret what they mean. So I'm going to erase the board. And I have a question for you. We have a new topic that we're doing today. We've got 40 minutes to present it. And I could either do it by drawing things on the board, or I could do it with slides. I have some pre-prepared slides, the same ones I used last year. We could go back to green screen mode, and I could point at my slides. Or I could draw things on the board and talk through them as we go. Would you like to do stuff on the board, or would you like me to point at PDFs? The PDF is online, so you may look at it. Everybody wants stuff on the board. Okay, all right. So, and this is better for you all too, because we have a couple of students down in the studio who are attending class in person. Everybody wants me to draw stuff. Okay. Pointing is boring, yes. The green screen was fun for the first little while, but it's kind of funny. Before COVID, I had to do this class in the giant lecture hall, and it was always a pain in the butt, and I'm fixing the camera by request. But now, it's kind of ironic. One of our students last year, who's now one of our coaches, Kirsten Edwards, said maybe being 6 feet apart will bring us all closer together. And now I can bring you a chalkboard to hundreds of students, just like you were, what is the camera, about 8 feet away? So you have so far been doing stuff with numbers, right? Your acceleration was minus 9 meters per second in the previous problem. In the bicycle problem, you've got velocities that go up and down, and sometimes they're positive and sometimes they're negative. But you've been studying positive and negative numbers for a long time. So you're familiar with the idea of a number line, right, where 0 lives here, and all the positive numbers live on the right, and all the negative numbers live on the left, right? We know this. We've been doing this since whenever it is that negative numbers show up in school. But we got to do better than this because the world does not live in one dimension. We've been talking about position, velocity, acceleration, but in more than one dimension, we can think of those things as things that have both an amount and a direction. So if I tell you my velocity, it's not just 50 meters per second, it's 50 meters per second that way. So I now need, so you already know how to do math with numbers, right? So here's the number 2. Here's the number minus 2.5. Here's the number minus 1. And I know how to do math with numbers. You know how to do math with numbers. But now we have to learn how to do math with arrows. So now we're going to need to, rather than writing 2 plus minus 3 equals minus 1, this is how we must do physics in one dimension. Now, we need to understand how to do stuff like this. Arrow plus more different arrow equals and I'm thinking just a bit. I need to know how to do this now. This is what our physics is now going to look like. This is what we must do in 2 or more dimensions. Jeslo says Wakanda forever. Black Panther was an awesome movie. And if you haven't seen the Black Panther memes that were made around the election, you should go look at them because there were some pretty epic ones. So how do we do math like this? Have you seen this sort of math? Where I like add some arrows together? Well, you have intuitively, right? Suppose you go to Manhattan. We have people from New York City here? We got the New York. I've been to New York City twice, and once I was laid up with just a splitting migraine, and I was in my hotel room, and I came out for 30 minutes to give my talk at a conference, and then I went back to my hotel room and cried. So in Manhattan, think about the grid of streets. So you know that if you walk 5 blocks north, and then 3 blocks east, and then 2 blocks south, you can kind of add up how much you've walked north and south and east and get the answer. You do one thing and then the other thing. Yes, Miles, this is vectors. Krolak says Manhattan is the best place on Earth. I am not a city guy, so y'all can have your Manhattan. But yes, what you do to add these vectors is you simply stack them on top of each other. So I might imagine doing this. So Here's the little red one. And then here is the blue one. Can you all see the dotted things on the board well enough?
Yeah.
Okay. I could also do it in the other way. Right? I could also draw the blue one first, and then draw the red one. So if I label these as A and B, and since they are arrows, we write them mathematically. And we'll label the green one as C. I can now write our first algebraic equation with vectors. A vector plus B vector equals C vector. And what I've done so far involves only arrows, right? I've done it with chalk, but I have magnetic things I could stick on the board, but I'm not going to do that now. So the pizza man is saying, yes, these are things with direction and magnitude, and people are arguing over whether things are real or not. Ohio is real, birds are real. But now we need a way to reduce this to something that we know how to do. But let's step back a little bit and introduce some language. Things that have magnitude and direction, like these, as people have been saying, are called vectors. They are quantities with both magnitude and direction. So in chat, what are some quantities that have both magnitude and direction that you know of? That both have a size and a direction.
Velocity?
Sorry?
Velocity?
Velocity, yeah. So some examples. So v with a little arrow on it. Acceleration. Which is a with a little arrow on it. Forces. We haven't studied force yet. But yeah, forces, like I push on something with a force of 10 pounds upward or downward. They've got directions. Some people have pointed out that speed doesn't have a direction. So this is a terminology thing. But not speed. Speed, the word speed just means the magnitude of velocity. Momentum. We haven't studied momentum yet, but it is also a vector. Another one that no one has named is position, which we use the letter S for. So position's derivatives are velocity and acceleration, which you already know. Now, I'm going to make this go away. So what I'm going to do in the next half hour, how are we doing on time? Yep, we got about a half hour, is learn to do math with these arrows. So you have learned already that in one dimension, you have two kinematics relations that tell you how an object's position and velocity vary with time. So you know that something's velocity as a function of time is its initial velocity plus a term that depends on its acceleration. And its position as a function of time is its initial position plus a term that depends on its initial velocity plus a term that depends on its acceleration. But in 2 dimensions, now we got these equations by doing calculus. Can you do calculus on arrows? Can you like take derivatives of arrows? Like, am I allowed to do that? Actually, yes. Yes, you can. You can do calculus on little arrows just like you do calculus on little numbers. So, and this is going to seem sort of stupid, and you're going to ask, why am I writing this? I can write down a vector equation that tells me how velocity and position change with time. Notice in the notation, vector position is s. This is because we're going to need the letters x and y for something else. Initial position. Well, helps if I turn the chalk the right way. So far I haven't done anything whatsoever that's interesting. Adam, if you could vet the YouTube link that was just posted in Twitch chat, thank you, and react as appropriate for being rickrolled or trolled. All right, thank you, Adam. So far I haven't done anything, right? You just copied these things, you replaced the x's by s's, and you drew little arrows over top of them. Yeah, that's all I did. But what I need to learn how to do now is I need to figure out how to connect these vectors to things I can actually calculate. How can I actually put an arrow into my TI-83 and add stuff to it? So I used an example earlier of navigating in Manhattan. But not everyone lives in Manhattan. I've spent much of my time out in the forest. And out in the forest, I might describe a certain vector with simply a direction and a magnitude. So here is a vector, and I might say, okay, this vector is 53 degrees above, say, east. Suppose I'm using my little compass rose here, where this is north and this is east. I might describe this as 5 kilometers, 53 degrees north of east. And if you are in a forest trying to find your way, this is a reasonable way to give directions, right? You set your compass to that value and you start walking. So this description of a vector is magnitude and direction. But I could describe the same vector, I'm going to draw the same little arrow, in a different way. How do you give directions in Manhattan? If you're not in the woods, but if you're in the city, how would you tell somebody how to get from one place to the next? Manhattan people?
Repeat the question, please.
Sure. How do you give people directions in Manhattan?
Open Google Maps.
What'd you say?
Tell them to open Google Maps.
You open Google Maps, yeah. People are saying like street blocks and avenue blocks. You don't, Joseph, yeah. Get on the subway and hope the train takes you to the right place. Hope the train shows up. Eddie says cardinal directions. Sorry?
Or call a cab.
Or call a cab, yeah. Maybe the Uber driver knows where they're going. It's really bad when the Uber driver gets lost. That's happened to me before. Like I was in Washington, I used to live in Washington, D.C., and I called an Uber, and the Uber driver is like, "Where is that?" And I'm like, "It's on Pennsylvania Avenue." Do you know where Pennsylvania Avenue is? Like the street the White House is on? Yes, Flexa Ruler. I used to live in Washington. Used to ride my bike past the White House every morning on my way to George Washington University to work, and I would wave at Obama. He was president at the time. But what people are saying is you use cardinal directions or blocks. I could also describe this on an XY axis, right? So if my axis is like so, I could also describe this as 3 kilometers east and 4 kilometers north. Whoops. We'll make the color coding consistent. So I've got then 2 ways to describe a vector. I can either do magnitude and direction, or I can do x and y components. How do I convert from one to the next? It's the same yellow arrow. So if I know, for instance, that a vector is 5 kilometers, 53 degrees north of east, how do I figure out that it's 3 kilometers east and 4 kilometers north? Nitor says I use trigonometry. The pizza man says I use trig baby. So this is a right triangle. So I can imagine, it's easier to see here, but the vector forms the hypotenuse of a right triangle. So and its components are the legs. Now, instead of labeling them x and y, I'm going to erase this and label them with symbols that are simpler. So if the vector is v, just capital V for vector, it doesn't have to be velocity, this leg would be v sub x, and this leg would be v sub y. So this notation that you've seen here, v sub x and v sub y, means the x or y component of the vector. Now, yes, I use trigonometry, but what trig do I use to convert from magnitude and direction to x and y components? What trig do I do to find vx and vy? We'll label them over here just to make it clear that this is the graph where we know them. I do sine and cosine. Yep. So here we know that cosine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So here, to go from magnitude and direction to the x and y components, I use sine and cosine. What if I want to go the other way? Sorry? I have to do some other trig. So if I know the x and y legs, what trig do I need to do to figure out the magnitude and the angle? I use the Pythagorean theorem to find the magnitude. Yeah. The Pythagorean theorem will tell me the magnitude. And to find this angle, people are saying that I use the inverse tangent. So now you know how to convert back and forth between the two representations of a vector. What do we do with this? How is this useful? Well, it turns out that the x and y component form is more useful. And here's why. I'm going to erase the board here. I got 15 minutes left. We're going to be a little crunched for time at the end, but that's okay. We have plenty of time next Tuesday. Believe it or not, today is the end of new material for Quiz 1. Next Tuesday will only be taking this material and studying how to use it to solve problems. So, remember before when I said that we could do calculus with little arrows? I'm trying to debate whether I want to do whether I have time to do a particular thing. Yes, I do. Okay. Suppose I've got two vectors. Here is A. And we'll say that the components of A are A sub x is minus 1, and A sub y is 2. And I have another vector B. We'll say that the components of vector B are 2 and 1. Actually, I'm just going to switch colors just to make things make a bit more sense. You don't need to redo your notes. I'm just using yellow here. By equals 1. So here I've got a vector that's 2 up and 1 to the left. Here I've got a vector that's 2 to the right and 1 up. Well, we know we can add these vectors by drawing them head to tail. So A plus B equals, well, I'm supposed to draw that one and then draw that one, right? So there's A, and there's B. Now, how do you think I find the components of this? So if A plus B equals C, what about the x and y components of C? How do you think I find these? I add the x and y components together. And exactly, and I can convince you of that by drawing a picture. So I'm just going to draw the little components in. So C, whoops, this is -1 and +2. Make this equation go away. Label them with chalk over here on this diagram. So if this is -1, that's +2. Let's see the components of that other one. I'm supposed to go 1 up and 2 to the right. Let's see, well, how far have I moved? I went 1 to the left and 2 to the right. So trying to figure out what color of chalk to use. There's my vector C. What is Cx going to be? I've gone 1 to the left and then 2 to the right, so what's Cx? Yeah, Dunes has given me them both. This is +1, I've gone 1 to the right, and I've gone up 3. So the big conclusion here is, now I'll erase these things, that if A plus B equals C, then AX plus BX equals CX, and AY plus BY equals CY. So, to add vectors, all you do is add their components together. So any equation that's true for the vectors is true separately and independently for the x and y components. So what does that mean? What's the consequence of this? Well, remember when I just wrote down that kinematics equation and put arrows over it? This means that all I get are 2 copies, one in x and one in y. So let's write that down. Yeah, what people are talking about in Twitch chat, it doesn't matter what order you do the things in. I drew them in the order that I drew them, so I would have room to draw everything on the board. But you could just as easily have done them like the other way around. So, what did I say before? I said velocity vector was an initial velocity plus a piece that depends on acceleration. And again, these are vectors. But this separates into 2. I know that this is true for x, equals v naught plus a t. Whoops. Shouldn't be putting arrows on these. These are the components. Walter, you're not thinking. So that's how you write the x component of v naught, right? So v naught has two subscripts. I'm just writing it again for clarity. It is the initial velocity x component. So that's how you say that. You just put the two subscripts after it. Plus axt. And in the y direction, vy is the initial velocity in y plus ayt. I just get two copies. Same thing for position. Position is, well, what did we say? It's the initial position, s naught, plus the piece that depends on velocity, plus the piece that depends on acceleration. What do I do? Let me catch up on chat here. Pizza Man, that is an amazing question. I will come back to that after this little bit. I just separate this out into two statements. I'm going to do this so it lines up nice and neat on the board. The x component of position, leave room to cross something out here. I just have s naught x plus v naught x times t plus 1/2 a x t squared. And then in the y direction, I've got the same thing. Plus v naught y t plus 1/2 a y t squared. Missing though, these ideas will be on the quiz, but you will get plenty of practice. Remember, the way physics works is in lecture, you learn what the ideas are. And in recitation and the homework, you learn how to use them. So you're saying, like, I'm lost. If there's a particular thing you're lost by, ask that now and we'll talk about it. But if you're saying, I see this idea, but I don't know what it means, wait for the practical thing because that's coming. But I want to, let me give an example. How do I use this? So I've got 3 minutes left. I apologize for the haste here, but I want to show you how this manifests. Again, you're going to get plenty of practice next week and on the homework. So there's a question in Twitch chat while I'm erasing. Are we going to use the Pythagorean theorem to find magnitude and direction? It's almost always easier to work with components. So often in these problems, you will wind up converting, if I give you magnitude and direction, you will wind up converting that into components and doing all of your calculations with x and y components. So in this problem, we have a person standing on top of a cliff, and they kick a rock through the air, and it flies through the air. I will tell you that its initial velocity is this way, and I'll give you its x and y components. We'll say that the cliff has height h. I am going to run 2 minutes over. If you need to leave, go ahead and do that. Um, Eddie, I'll address your question in an email or after class. I want to get through this. I will run 2 minutes over. If you need to, catch it on the recording. But we'll come back to this. This is where we're going to start Tuesday. So if you need to leave, go ahead. Actually, forget it. We have plenty of time. We've plenty of time. We'll pick up here because all you're doing in recitation tomorrow is practicing converting vectors from magnitude and direction and back. So we're where we need to be on the schedule. I know we did a bunch of abstract math today. This is the only day in the semester we're just going to do math. All I did today was I talked about math with arrows, and I ran out of time to do this. But that's fine. That's what we're on schedule. Tomorrow in recitation, you're just going to practice doing math with little arrows. It's a super important idea. We're going to spend a whole day in recitation practicing it. And then next week, next Tuesday, we're going to learn how to apply this to this person kicking a rock off of a cliff. So position as a function of time equals question mark. We're going to do that Tuesday. We're out of time. I will answer questions here at the end of class, but if you need to leave, please go ahead and leave. And let me get all your questions. Thank you all so much for bearing with me as I got the new broadcasting setup built. We've moved to the new computer. Everything will be smoother. Update on in-person lectures for tomorrow, in-person recitations. NJS, if you would like to, NJS, are you in the 8:30 section by any chance? Thank you, everybody in Twitch chat. I appreciate you all. This is no fun for me, right? I miss seeing my students in person, and I get to see 3 wonderful people in person, but only 3 of you. There are tons of you. I would much rather be in person with you all, but I really appreciate you all coming to visit. But will the work be? Find out next episode. NJS, what section are you in for recitation? We'll get you set up. Beck Munch, you really want to be in person tomorrow. What section are you in? If you could type that in Twitch chat. In-person recitation will either be it's whatever it was on Wednesday. But the 8:30 people, we will be able to accommodate in person on Friday. Tomorrow, you will be in person. I will send out instructions. We have people to teach you in person at 8:30. Stay tuned. Have a supreme day, Dunes. Sidney, from the first problem, this is number 5 on the homework. When you're answering the question, should you restrict the domain specifically or should you disregard the extraneous value? They mean the same thing. So when you say restrict the domain, that's a math way of saying figure out which value is extraneous and disregard it. So you may either think about it like a mathematician and say the domain is here in which this applies, or you can think about it like an engineer or a physicist and say this part of the parabola doesn't make any sense. Either way is fine. MM Mathis, you may of course Google, but you may also estimate. Ian Storrs, in-person recitation will either be in 112 or the basement. It'll be whatever it was before. Siddiqui says that they're looking to make a remote study group. If you want to coordinate that by email, go for it. Thank you all so much for coming in person. I hope I've not been talking too loud because I got the headphones on. We will have things better for you set up later. Question for everybody. Oh, Dragoon Slay X, can you sit in on multiple recitations? Absolutely. So Sydney asks, are there outside sources you can practice with? So you want more questions, right? You want like more stuff to practice. I have a resource for you. So we had a practice exam last year. Well, here's what I'll do. I will send out the exam from last year to you. Well, no, we had a practice exam last year that was even longer. So we have a bank of 8 questions that we gave the students as a practice exam last year, and we'll give that to you again this year. This year, you will also have a practice exam on Wednesday. I will tell you all about this in the email. But you'll have a practice exam in your recitations on Wednesday, too. So there'll be lots of things you can use for reference. Uh, Other sorts of questions. NJS, Friday at 8:30. Yep, we will have somebody there to teach you in person. Her name is Caitlin, and she is fantastic. So Sydney, I'll send you those resources in the email digest today. Any other questions for us?